I am Janusz and I will talk about nuclear power plant inspection with MANDEYE mobile mapping system. I will tell you about creating a 3D map, 3D model from data collected with MANDEYE system. You can see on the right, and the point cloud, the result is supposed to be, as you can see on the under the cursor. And this work, give me a second, I will just close it. Yeah, this work is related with open source, open hardware handheld mobile mapping system for large scale survey. This paper can be found in this journal, and some people found in this paper that with the mobile mapping system we can create such models, and in this movie I would like to tell you how to do that from scratch. And obviously speaking, if you would like to have this data, please send me email so I can facilitate you with data and maybe more knowledge that you need to create such maps. Here is another let's say trajectory of another survey. This is done in shopping mall, and you can see trajectory and the final error after LiDAR odometry not exceeding certain meters. And obviously you can use this system for making larger maps. More information you can find in this project, and you can find my email here. So let's back to data. So our data is organized into session. I will open this file and I will show you how to read most important information. So this is JSON file, and data is processed with LiDAR odometry version 0.74. Total length is almost 4 kilometers, and data is organized into LAS files that they are, let's say, local point clouds, and the transformations are in poses. So each file, each LAS file has its own pose. So you can see we have 712 poses, and for example the first chunk has this pose, second chunk has this pose, and then the third one this pose. Now the most important is to investigate if our data set is correct. We have session, so let's investigate what we have in this session. So we open MANDEYE single session viewer, and we open this. So let's back to this. So we load session. We load session and wait a little, because we have 712 local scans. So obviously we can during the loading we can do something more. So let's see what we have in one local scan. Oh, this is one local scan that it is prepared by LiDAR odometry. So it is like certain seconds, certain meters collected into one rigid scan. Okay, so let's back to our inspection tool. It's almost done. It's almost done. Okay, so we have our data set. We spent 1 minute to load it. Now we can inspect. To inspect it, we are looking for certain suspicious chunks that the data is not sharp. I will demonstrate it to you. For this reason, we can also support with neighborhood, and we can see that everything is is quite correct. We can investigate. We can investigate. It's quite okay. It looks like not so big problems. Okay, so the error is not so big. You will see after a moment that once I find a certain problem, then it will be easier for you to understand what I'm looking for. At this moment, please believe me that everything's supposed to be okay, because all let's say structures are quite okay. Let's make it faster. Okay, so I can see. I remember when this survey, so I can see that everything is okay. Everything is okay. Let's go. Let's go. Oh, now we have problem. Okay. Can you see? We have two levels, but this is one level. So this is the suspicious moment. Obviously speaking, it is not so trivial in the beginning to find such a problem, but believe me or not, if you have a sharp data here, and then you can see some corners, you can see some short things, and suddenly we have something like this. Can you see that it is suspicious? 343. Let's save it. 333. And let's continue our investigation, yeah, of suspicious elements. Okay, we continue. Obviously speaking, I did it many times, so in this particular data set, I know that we have two suspicious elements. So if you do this, then you will be much slower in the beginning. So let's jump into the second one. This looks good. It looks good. Looks good. Looks good. Okay. This looks good. Looks good. Oh, something wrong. Can you see this wall? This wall is not correct. Okay, so let's find the suspicious one. Oh, this one. Can you see that this is suspicious because it should be sharp like this, but this one gives you certain meters error. It is 696. Let's make it noted. 696. Okay. So let's close our. Oh, sorry, not closing. I think it is the last one. Yeah, let's close it now. So we have two suspicious elements. So let's open our session in step second. So we open second step, and then let's load our session. And obviously we have to wait a little because it's plenty of data, 4 kilometers of data, and is loading in 1 minute. Okay, data is loaded. Now it is downsampled and indexed. It means by indexing that we know which point corresponds to each element of the trajectory. Everything is with timestamps, so it will be very easy to make some calculations. Okay, so it is loaded. Our trajectory is like this, and we have some initial structure. Okay, we can see some errors. So let's split into subsessions. To do that, we have to unclick Simple GUI We have to go down, and we can hide all, and here we can jump into 333. So index will be 333, and we show selected. And let's see if our subsession is quite correct. Here we have points that information that we can downsample or not. Okay, so it was here. Oh, can you see? This is the trajectory element that we jumped down. It was suspicious, so now it is evident that it is not correct. So what we have to do? We have to remove this particular element from trajectory. Okay, I will remove another one. Okay, so our subsession will be from 0 to 341. Let's observe, do we have some suspicious elements? It looks very promising. It looks very promising. Yeah. It looks quite okay. So what we have to do now? We marked our chunks. For this purpose, we put 0 and 341, and we clicked show selected, and now we have to click save subsession, and we have to remember which one for the naming. It was 341. Okay, 341. Okay, so we save subsession and we save session. So we have session 0341. I will check. Yes, this is the name. .json, and we put save. And now we have to save initial poses. So our initial poses will be also the same name. Okay, save, and we have to save final poses. So we have poses 0, 3, 4, 1, as far yeah, I remember. Okay, so we have subsession. So let's save another subsession. Another subsession will be from 342 up to 696. 696. We show selected. Okay, so we have to remove some data. We have to remove from here, so maybe this one show selected, maybe 5 more, even more, 6, even more, 7. Okay, so this I will add another to be sure. Okay, so I'm sure, and then it looks okay. It looks okay here. Everything is flat. But here we have some suspicious trajectory. Okay, this one. So I will put it 5. Okay, now it is quite okay. And let's take a look if our model, if our odometry is promising. It's quite okay. It's quite okay. Okay, this subsession looks very promising, but I can maybe not everything is promising because chimney is not good. I will try to remove more. Okay, maybe 350, or maybe even more. Even more. We will put. Okay, this one, or even I will put. It's quite okay. It's quite okay. Okay, so we have 353. 353 up to 695. So let's make a subsession. So we show selected, and our subsession is almost ready. So let's save subsession. So our subsession will be this name. So we just name it. Something wrong. Okay, this one. Initial poses also we will change the, and poses we also change. Okay, so we have this subsession, and the last one will be from 695 697 to the end, show selected, and let's observe if everything is okay. I don't think so. Maybe it looks weird, but it is quite okay. If we have certain problems, then we will fix it in the end. Okay, so we will save it. So we have 697 to 711. Let's save. So let's save this subsession. So we show selected, and we save session. So we have session. We have to save initial poses, and we have to save final poses. Okay, so we have 3 sessions. We close the program, and back to our data. You can see all is organized very well. So let's make loop closure for all subsessions separately. So we open again our step second. We load now our subsession. Our subsession is 0 to 332. Due to the fact that we have much less data, loading will be much faster. Okay, so we have subsession, and what we have to do now is to make some loop closures. For this reason, we just put it more data to see it much better, and we can see the chimney. We can see some errors here. So let's do some corrections. So we have manual pose graph loop closure mode. We click it, and now it is enough that we find some intersections, and we add some edges. So we have, for example, here 35 and 32. So we add. Oh, sorry, no. We have to remove this active edge again. So we have to put 32 and 45. We can add change some colors, and you can see we have some small errors. To reduce this error, we have to manipulate this edge. We have to add this edge. So it is our index of edge is 0, and it is between 32 and 45, and we manipulate it by iterative closest point. And the error is quite small, so we can just click it several times and wait the moment that it is not moving anymore. Okay, so we have this, and then we just back one step before. We observe here, and we set initial poses as a motion model, and then we compute pose graph slam. Okay, so it is calculated, and now first error is taken into consideration, and you can see that data is starting looking much better. Okay, let's find another error. For example, we have some very nice moment that we have this, let's say 107 and 135. And again, we can add this edge, and we can simply click iterative closest points till the moment that it is not moving. So for example, I clicked 5 times, and you can see that the edge looks very nice. We can back here and we can compute again edge. Oh, here I have very nice 83 and 147. Okay, we have this one. The error is already centimetric, so let's add edge and click twice or 3 times. Oh. And then again compute postgraph slam. Okay. And again we look for something interesting. For example, 166 and 179. And again we can see some displacement, so we add this edge, we perform iterative closest points till the loop, till the error is not big anymore, and then again compute postgraph slam. Let's continue. Maybe here something, maybe 184 184 and 202. Okay, you can see that the idea is to find some corresponding nodes in trajectory, adding edge, and then minimize error on this edge, and then computing postgraph slam. So you can see that we have repetitive similar activities. So let's continue. Add edge, and then manipulate, and then compute postgraph slam. Obviously, if you would like to play around and if you would like to have fantastic result, you can add edges and add edges till the moment that you will be satisfied with the results. The data is so big, so you need plenty of edges to address all displacements. We will not focus on that in this particular movie. You can do it by your own. So let's compute this one and suppose that we are happy with this result. So we have first session aligned. It is looking very promising. To investigate how it looks, we can simple save scans as OTMP LAS. Before we save session, for example. Okay, we saved it, so let's take a look how it looks in Cloud Compare. This is training movie, so we will not focus on super accuracy and precision, and this is like a training video, so please keep in mind that it can be done much better once you investigate more and more edges and so on. Okay, this is in the middle time you can investigate your model in Cloud Compare. Colors correspond to timestamps, so you can see that from the blue to the red one how you went. Yeah. Okay, we can obviously agree that is acceptable for this moment. We can continue. So let's save our session. So save session. And our session was this one. So we saved as the same session, so we overwrite our session. Yeah. Obviously, you can save in different name, so you can keep your previous data. Okay, we close the program. Let's focus on the second trajectory. We do the same, exactly the same. So we just load session. Our second session is this one. We wait a little. And then we can do exactly the same. For this reason, for this purpose, okay, so let's find some loop closures. 98 and 213. Let's generate random colors to see the if you don't like the rotation place, you can simply press Ctrl and middle mouse, so you can change the rotation. You can see like this. Can you see this one or this one? This is the center of rotation, so it is quite useful tool with this GUI. Okay, we add edge and we simply make iterative closest point as before. So you can see that we did it already 15 times, always the same. So now we set initial poses because it is the first edge, and we optimize. Okay, let's find another one. Maybe this one. 159 and 123. Okay, so this is this one. We add this edge and let's minimize error on this edge. Okay, and then we calculate. Do we have something more? Yes, we have plenty of places that we visited. Maybe 300. Maybe 310. And 75. Oh, this is very nice situation that we have very big error in the Z level. So we add edge, we manipulate, and we will use Gizmo. So you can see that once you have too big error, to minimize it automatically, you can use Gizmo. Let's continue with iterative closest point. Let's inspect some. Oh, it is not yet. So for this reason, we can just increase our search radius to ½ meter, and you can see that it will converge with larger error. But finally, let's do it for 10 centimeters. Okay, we have this one. And then we can recalculate error. Do we have something more? Yes, we have, for example, 182 and 169. Okay. So we add edge and let's make ICP. I will change colors to be more sure about this. Let's make ICP. And make photographs. Now, I'm quite happy of it. It's quite promising. Maybe we can add this one, 2, 2, 2, and 2, 6, like this. Oh, good choice, because it is outside. So we add edge, we put half meter, and we make ICP, and you can see that it is converging. Very nice. So let's back to this complete postgraph. Okay, so we have quite nice results. Maybe this one will be also very interesting. 73 and 313. Oh, you can see that during the process, once you add more and more and more edges, the system is much better and better. Okay, maybe we can add also this one, 139, 150. Okay, we add and we make ICP. Oh, the error is centimetric, so let's just agree that this is what you want. So now we save session. Our session name was this one. So we just override, and we have overridden session. Let's open last one, session. And let's make a loop closure on it. This very short session, so I can see that it's quite impossible to improve it because it is, the trajectory is too short. On short trajectories, small projects are very well aligned in this LiDAR odometry. So we close it. So we have already 3 sessions that we can combine into a big project. So let's start with multi-session registration step 3. What we will do now, we will concatenate all we did in previous step. Okay, so let's add session to project. So what we do now, we concatenate all things we did before. So we have three sessions. We have 3 sessions to concatenate. We have this one. So you can see it is added. We add another session. And we add another session. So what we have so far, we have session, but it is sub-session.